right, so good afternoon, everybody. We'll get started. We're a little bit late already. Are we good with the video at the back? Are we good with the recording? All right. So today we'll be talking about Coresight, what we've done over the last year. So believe it or not, it's been 1 year that Linaro has been working on Coresight full-time. So we're very happy about that. So in the first part of the presentation, we'll be talking about what was accomplished. So we'll go over our initial agenda, what we wanted to do. We'll look at what we thought we'd be doing, what we ended up doing, and what we did not see coming at all, because there were things that we never imagined that would happen, and indeed they happened. So we'll go over that. The second part of the presentation will expose what we want to do for the remaining of 2015. So there are things that we think are important. We want to share that with you, and from there on, I'd like to see if you have any ideas on things we can improve on, or things that you don't agree, or others that we might prioritize. Okay, but I think that for the most part, based on what we've done and where we're going, hopefully we're accurate. So there was a previous slide, the slide deck. There was a previous version of these slides. There might be small discrepancies between the two. Nothing big. It's simply that the slides were created early in January, and a lot of things have happened since then. So information in here should be considered accurate or superseding the ones that were previously released. Okay, so if we go back in time 1 year in Macau, almost day for day. So we talked about, the things that we, our initial goals and things that we said we hoped that we would be working on and things like that. So we'll also talk about what we're going to be doing afterwards. So our initial list of goals. So back in Macau again, our main goal was to upstream something that would serve as a foundation for people to start building on. Okay, at the time there was nothing in the kernel, nothing was supported. And whatever was there was very minimal and architected for one SoC. So we took the code that had been released by Code Aurora, addressed the comments that had come back, and started iterating and doing multiple releases with the community to see how things could be improved. So 9 versions later, 3.19, 3 things were accepted for merging. Right? So that includes all the plumbing that takes the traces from a source to a destination. Right? So we're talking about funnel, replicator here. We have a stub driver for TPIU, an ETBU, basically an embedded trace buffer that collects the trace, so that's a sync. The buffers for those. And we also have drivers for the ARM32, so ETM and PTM. Those are the tracers for ARM32 processors. So that's all in submission that was accepted for 3.19. What we also wanted to do is come up with a library that would allow people to decode the trace stream that is collected. And last but not least, we were hoping to integrate all this into the CI loop at Linaro, so that whenever we accept patches from the community, we'd have a certain level of certainty that it would not break the code that is currently there. So this is the main lines that we've had. This is what we wanted to accomplish back in 2014. Okay, so 1 year later, as I mentioned, everything was accepted upstream, pretty happy. We added support for 2 more boards. Initial support was for OMAP3. We kept OMAP3 in there, so it's backward compatible. We added support for the VExpress, the big little platform, and Huawei's D01 board. So these boards are currently running in our CI loop in the Lava Lab. So every time that there's a patch that's coming in, a build gets triggered, and the minimal test suite is started on those 2 platforms. We don't currently have BeagleBoard and BeagleXM in the Lava CI loop. So as I mentioned, the drivers were accepted. Pretty happy about that. With regards to decoding, we did not quite come up with an open source library. What we did is took the DS5 from ARM, and we fed the result of the trace acquisition to the decoding library that is embedded in the tool. It does require a little bit of black magic, but everything is explained in the reference there that you'll find at the end of the slides. So anyone who would want to do that with their platform can do so. Again, it requires a bit of intimate knowledge of how DS5 works, but there's nothing that is too intricate there. We talked about integration in the Lava Lab. So things we still need to work on. The library front, we thought would be spinning off our own or implement or enhance the ones that were currently there. So that ended up being a lot more complex than we wanted. We probably would have required someone working full-time on this. We simply did not have the cycles nor the manpower. So what happened is that we turned to people at ARM that were expert in the area and asked them for help. So that is currently being worked on. From what I understand, there's an implementation that has been realized, and it's a matter of getting it through the lawyers. So this is something that I'll be working on with the ARM people here at Connect this week, and definitely that in the coming weeks or the coming months, we should have more updates on that. But a library, standalone library that we can use to decode generated traces is definitely something that will be coming from us, hopefully in 2015. Okay. Power management. A year ago, you would have told me about power management in Coresight, and I probably would have brushed you off. But it quickly became clear to us that power management and Coresight are things that go hand in hand. Simply because if you have traces that are being collected and another device in the same power domain switch off the power domain, well, you're losing all your traces and everything you were gathering. So I spent a lot of time looking at the runtime, power management, and generic power domains. All of the drivers, I have a prototype that made all of the drivers runtime PM aware. That has not been published yet, simply because I haven't ironed out the part that hooks up with power domains. So the idea is to use the power domain subsystem in order to model the two schemes that Coresight work with. First scheme is that all of the Coresight blocks are in the same domain. That does not include a CPU, or they are in a domain that is included with a CPU. And that is where the problem arises. So we'll talk about that later. So for now, definitely that power management is something that we did not see coming, and that we had to kind of catch up as we discovered things. Okay. At first, what we wanted to do, I was probably dreaming in color, but I was hoping to get support for at least 10 boards. To me, it was just a matter of coming up with the right pieces in the device tree in order to generate different path or different topology. If the drivers are vanilla and if the IP blocks were vanilla, it would simply be a matter of switching on trace collection and everything would work. The problem here is that, again, power management, I did not envision that would become a problem. So when it was time to enable or to switch on these devices, we couldn't, simply because either the API for those boards was not upstream or non-existent. So we worked with a fair amount of vendors, and in a lot of cases, we simply did not have the tools that we required to do the things properly, and the vendors did not have the resources to help us in those ventures. So this is something that definitely prevented us from supporting more boards. On the flip side, we still continue working with these people so that at one point or another, their platform gets supported, and we can port Coresight to them. Okay, so that's the first part of the presentation. again, main thing that happened in 2014 and the first part of the year is the acceptance of the framework upstream. So we're very happy about that. When I wrote the slides, I hadn't pushed yet an STM driver. So I did that last week. I published an STM driver that take its source from Code Aurora, modified a whole lot of things, and published that as an RFC. So some comments have started to come in. So that's also something that should be interesting because a lot of members were asking for the STM, the static trace macrocell. Okay, so for 2015, the remaining of the year, definitely that ARM v8 is very high on our list. It's already started working on Juno and another platform from Huawei. ETM v4, we talked about ETM v3 and PTM 1.0 and 1.1. Those are the tracers for ARM32. ARM64, the tracers is ETM v4. So there is a driver for that currently being tested. That implementation is a lot more complex. So the ETM v4 is a lot more complex than the tracers for 32-bit. So it requires a fair amount of ramp up. And right now, my attention is elsewhere. So ARM v8, ETM v4, STM32, STM500. We're working with ARM on STM500. Power management, there are people from power management group, CPU idle, and maintainer for the TC2 that are here this week. So I have to talk to them in order to find a solution to the problems that we have with power management. Integration with Perf and Ftrace, that's mandatory. Everybody's using these schemes, so definitely Perf has an interesting way of gathering trace data and metadata together in the same package. I'm not a Perf expert. And definitely that doing this, your opinion matters. So if you think that after today, if you think that we're making a mistake somewhere or that we're not paying enough attention to specific areas, come and find me, and we'll be happy to. I'll be happy to help you, or to discuss things on that we can improve. Okay, so support for ARM v8. We have two platforms that we're currently working with. Platform from Huawei, so the B6220 and the Juno platform. So support for that is well along the way. I know that people at Huawei have created a device tree. I can't say generated traces because we haven't tested on their platform yet, but all the plumbing is in place. I have a patch that is floating upstream that is enabling all of the IP blocks that are already 64-bit compliant to be compiled in, to be configured. Support for ETM v4, that's also in my personal tree, has been published on my Git repository at Linaro, but it's not public yet simply because it's very rough and I haven't had enough chances to test it. I preferred to favor testing with STM32 simply because it's a lot more simple and people are asking for it before ETM v4. But definitely that ETM v4 will come in as well. That's just a matter of time. So ARM v8, we want to provide as much support as we do on ARM32. And ETM comes into that as well. STM32, STM500. Juno has an STM32, which makes my life a lot more easier. So I can do, I can basically get progress on two cards and using the same platform. So right now, I was able to generate traces using STM32. I programmed a small application that is simply writing things into a channel, and I can see that my data at the end in the buffer. So pretty happy with that. As I said, the driver was submitted, and I have people at ARM that are working on STM500 on a platform that is internal to them. So STM32, STM500, the bulk of the work in that area is to come up with a management scheme that will allow to make sure that channels are properly reserved for different entities in the system. And that is not something that I will decide, it's something that the community will come up with. Linaro is planting the seed, and we just want the people to start growing it and nurturing how we're going to do this. So in the driver, I have a very small management, very small implementation of channel management, but it's just for the purpose of testing and demonstration. After that, we have to come up with something that is more intricate that will basically fulfill everybody's requirement. Okay, power management. As I mentioned, there's two scenarios that we have to deal with. A scenario where our IP blocks are not part of a domain that includes CPUs, and the opposite, where we have Coresight IP blocks in the same domains that CPU would have. So the example of that would be on a TC2, where we have clusters of CPU, and within those clusters, we have tracers that are associated to them, right? So at one point or another, CPU idle or MCPM decides to switch off the cluster while traces are still being collected. Poof, you lost everything. So the idea here is to use a kernel subsystem called generic power domains. So this is already there, it's already being used, except that there's only one platform linking those generic power domains with CPU idle. And that has to change, right? It was working properly for one CPU, but there's a lot of mechanic that has to change in order to make that, in order to support multiple CPUs. So this is something that, again, I have to discuss with the people, different maintainers here, to see how we're going to do this. The other case that we have is where Coresight IP blocks are in their own power domain, or that they share the power domain with devices that are not CPUs. For that, we can simply use generic power domain instantiation. I should have a patch for that in about a month for Juno. I already talked to the maintainer this morning. So for cases that do not include a CPU, it's pretty easy to do, right? It's definitely not the end of the world. But for cases that do include a CPU, we won't have a solution that will be, we won't have a quick solution. So we have to talk about that. We have to see how we're going to do things in order for people in the power management domain to continue evolving this scheme further, because there's something more that they want to do with that as well. All right. So there will be discussions on that this week. Integration with Perf and Ftrace. Kai, a assignee from Huawei, is solely working on Perf nowadays, simply because people are asking for it. This is something that came up as of prime importance. So I took on the enablement on ARM v8, and Kaiju has started working on how to integrate Perf, or how to integrate Coresight with Perf. Yes? I've been specifically asked to pass the microphone around.
Just to be sure of the direction, you want to integrate Coresight stream in Perf tools, or to integrate Perf output in Coresight pass?
No, the other way, the first one.
The first one.
Basically, Coresight's output into Perf.
Okay. And the same for Ftrace, for the trace?
Right, so Ftrace, what we want to do is take the Ftraces that are coming from the kernel and dump that into a Coresight buffer, not the other way around, okay? So I foolishly thought that integration with Ftrace would take me a couple of days, but then I attended a talk from Steve Rostedt at Linux conference back in Germany in October, and I was wrong. So the way I wanted to do would introduce delay on the Ftrace path, and he basically had a set of slides on how to do things properly. And yes, I need to do a lot more homework in that area. But this is something that is so integration with Ftrace will likely come once we're done with Perf. right? We would like to favor Perf simply because Intel has favored Perf. It's just normal that we follow along the same line. Just so that, not because it's a competition thing, but just because it's easier for people to work with the schemes if there's already someone that has done it. All right, so that's where it's your chance to talk. It's your chance to give your opinion on what we're doing and what we've done so far. I don't know how much you've been following this, but in the year or so that we've been working on this, we've had input from Qualcomm, TI. There's tons of people that sent emails out of nowhere, giving valuable input, and I want things to continue in 2015. I think right now we've done the boring part, the part where all the plumbing is in place. Now it's really up to companies to take that and port what they have to the framework, offer more diversity, offer more support for different parts, different SoCs. The opportunity is really there to make yourself heard, to carve the path into this new subsystem that we have. Right now, we've only set it's only a yardstick that we have, right? There's so many interesting things that has to be done, and it's definitely up to you to participate and join us in that venture. Right? So if you have ideas, if you think we've erred somewhere along the way, just come and find me, send me emails, talk to me in the hallways. Even here, we have microphones. Super happy to hear from people on their ideas and what they want to see happening. You have a question, Christian. Go ahead.
It's about the library. You mentioned the library where you had some difficulties to make it work correctly with the S5. I guess this is a library that presents an API that we can use to integrate into a given framework. Should it be the S5 or something else?
Right. So what we've done here, our goal was to have a standalone library that is completely open source, independent, is vendor neutral. But that did not happen simply because we did not have the manpower. But we still needed to prove that whatever the framework and the drivers were generating was valid before we could push them upstream. What happened is that we took what was readily available in DS5 in order to prove that what we were working was correct. Okay? This is definitely just a stepping stone toward the right way to do this, which is with a standalone library that we don't have at this current time, right? We've enlisted help from people at ARM in that area, simply because ramp up would be too expensive for us and extensive, and we don't have the manpower. So if we want to be competitive and if we want to do something, we need to start with an implementation that's already there, and they already have an implementation, and we need to tap on their knowledge. So we used a DS5 simply to prove that what we had generated was correct.
But still, it's not on your list in 2015, is it?
Oh, yeah.
Yeah? So I missed something, maybe?
No. Or maybe I just missed it in my slides. But having a library to decode the traces is extremely important. If we don't have that, we cannot integrate with Perf, right? We cannot integrate with user space tools. We cannot integrate with anything. So that integration will not be done by us, but we have to provide the building blocks for people to be able to do that.
So it's in your plan?
Absolutely.
Okay.
Absolutely. I might not have made it obvious simply because right now we're not currently working on this as Linaro, but we are working on it as Linaro with ARM. Right? ARM is definitely doing the bulk of the work in that area right now. Anyone else?
I have a question. As you know, for the ARM, developing, it's very difficult to debug one kind of issues, that is system hang immediately and without any signs. So is there Coresight can help it or not?
That's what you would typically use Coresight for. So you have a system in production on an assembly chain somewhere in a car, in a aerial vehicle, the system hangs. Everything up to that last instruction is saved into the buffer. And as long as the buffer is powered, you can do whatever you want with the platform. That information can still be retrieved.
Yeah, as I know, for the ETM trace buffer, even the power is off, but when next boot, the data is still there, right?
Right, so that becomes an implementation problem. That becomes what happens, when the system fails. Do you put a JTAG on it to retrieve the traces? Some people do that, right? Do you have a scheme by which the power domain in Coresight is completely independent from everything else on the board, so that whenever you do a soft power cycle, that domain stays on, and as such, upon booting afterwards, you have a flag that says, go read the data in there. The main point to remember here is that the mechanic exists. It only needs to be used properly, and that becomes a platform-specific challenge. But it's not easy. I agree with you. It's not easy. I totally agree with you. But I still think that it's the best thing that you have right now in order to do this type of operation.
Yeah.
Specifically if you don't have a JTAG running on it when it does happen, which is more and more the case nowadays, because it's impossible to think that a system that is extremely small will have a JTAG connector. It's not realistic, right? So I hear you. That's why we're doing this. That's why the demand for this started.
Thank you.
All right, there's a cookie for the best question. All right, I have a cookie at the restaurant for the best question. Come on. People from ARM. Guillaume, ask a question. You must have a question. We've been doing this for a year now.
Anyone?
All right, if it's all good with you guys, we'll keep going as we're going now. And definitely, I'm just amazed at the amount of mileage that we've done in 2014. I can only imagine what it's going to be like in a year from now. So stay tuned. And as I said, it's up to you to chart wherever this is going. Now is the time for you to get involved. Now is the time for your company to port to Coresight and start using it. Presentation's over.
Oh, sorry. I win the cookie. No, so once we have developed our driver for our platform, I haven't looked in details in any documentation. So we need to create the path with all the Coresight IP. Is there any command line application that can create this path automatically?
Yes, the framework does that for you. So the Coresight framework, whenever you boot, will, at runtime, it's done using source and destination. And the path between them is known using the device tree. So from the command line using sysfs, and everything is documented under documentation, you enable a sync, you enable a source, and that's all you do. The framework will take care of setting up the path in the Coresight network.
And if there is several possible paths?
Absolutely. But there's only one path between a source and a sync.
Okay.
Right? You can have multiple sources tracing to the same sink.
Yeah.
That's not a problem. You can have multiple sink for the same source.
Yeah.
That's not a problem either. As long as you enable them at both ends, the framework will generate the path and traffic will flow.
Okay.
That's also one reason why we did this, is because using a device tree specification, you don't have to reinvent the wheel anymore. You can have different SoCs with different IP blocks in them using the exact same drivers. All you have to do is modify your device tree. If you want to isolate components, you simply remove them from your device tree, and that's it. You have a different system. Right? So the idea is to make things as easy as possible. And I think, well, we've proven that we have the beginning of a solution, simply because we were able to install it or port it to 5 or 6 different platforms without having to touch the framework at all. Everything was device tree specific. We laid out our topology in there, and poof, it came up. We didn't have to do anything.
Correct.
Kate. Presentation's over.
I couldn't resist, sorry. We've got handling for device tree.
I can't hear you.
We've got a handling with for device tree. What about when we are trying to work with this on servers that are booting through ACPI?
We haven't tackled that case yet.
I'm thinking maybe.
But I don't imagine this to be, because there are ways to go from ACPI to device tree. All we need is hardware to do this, right? All we need is one. All we need is one.
Yep.
If we have a case, right, that we can start modeling from, definitely that we'll get interested.
Good, okay.
But something like that, this is a perfect example. Something like that would typically have to come from the community.
I'm just thinking of some boards that are showing up. I'm just thinking of some boards that were announced today and were showing up
Right,
eventually, so
right.
maybe
So,
in 6 months' time we'll have something.
as I said, we just planted the seed.
Yep.
Right? For people to start working with.
Thank you.
All right. Oh,
I have a question that because now for ARM8, they have the exception 3. This is for untrustworthy, and the kernel usually run in the exception 1. So, for example, if the core wanted to do the CPU idle and want to be powered off, then at that time point, it needs to flash the ETB or the ETM because the core will to be powered down. So maybe at this time point, the year 1 has the permission to do the flash operation or not, or we need to do the flash in the year 3. I'm not sure. Flash out, because the buffer maybe need to flash out. So because I saw in the slide, I only see your work is only focused on the kernel, but there have some works related with the untrustworthy or not. I'm not sure. Just a question.
well, is there I haven't got your question there. There's a lot of information, but I'm not sure I got a question.
Oh, okay. I mean that maybe when the core powered off, then there have some operations related with the ETM, and these operations need to be done in the year 3, this level, rather than in the year 1. So, because I think that, for example, if we want to access some register related with the ETM, we want to flash the ETM buffer. Right. Then maybe we need to switch to the year 3 to do that.
I think that's a platform-specific thing. Right now, everything is available via sysfs. All the operation that can be carried out is via sysfs. At one point or another, we might provide IOCTL commands that could be accessible from a user space monitor, a user space program. I'm not against that. I simply haven't done it because I don't have a use case for it. So if you have a use case, I'll be happy to look at your patches. But again, I need an instance of someone who needs to do something like this. And this is a perfect example of the community stepping in to grow this scheme. Yeah, it's just something that we did not need so far.
I think maybe they have some more detailed. We can discuss with the patch. Okay.
Who is this for, if you can say?
I mean that because before we have developed the code.
Right, but who do you work for?
Now for the Linaro.
Your work? Oh, okay.
Okay.
Then we can talk later. I'll be interested.
Just one last question about the timestamping.
Yeah.
Have you got a common timestamping for all the trace?
Yes, all the trace will work on their own. Within the Coresight framework, you have common traces. You have common timestamp. The problem becomes when you're correlating with the kernel timestamp.
Yeah.
That's not done.
Okay.
That's a problem that is being worked on. I'm not in tune with the progress that's happening there, but it's definitely a problem that we're aware of, but we haven't solved yet.
Okay.
That's difficult because it's difficult to do within one CPU. Imagine all the entities of the system.
I have in mind some IP have some internal timestamping, so you're able to timestamp when you write to that.
Yeah, the Coresight blocks will have an internal clock input.
Yeah.
So the pins are there, the registers are exposed, we just don't do anything with that. Yeah. I think we're right on time. That's cool. Perfect.
Hi. So yes, you said that you got a lot of help from ARM, but I think we can thank you as well for all the work, the hard work you did to push everything upstream. I think it was a very good job. Just a quick question. So when you will finish all your to-do list this year in 2015, after that, is there any features in DS5 or any other tools from TI or Qualcomm that won't be upstream in any upstream tool?
What's the question? Sorry?
So I believe that in DS5 there is some support for Coresight and from other partners like TI and possibly Qualcomm as well. They have their own tools. Do you know if any features that they have in their proprietary tools won't be in any open source library or open source tool?
So if I understand correctly, the question is if vendors like TI, ARM, or Qualcomm have anything in their environment that will not be in the decoding library. It's very hard. Coresight is just one thing. If you take DS5, for instance, DS5 does pretty much everything you want. So we will concentrate on what Coresight can do. It's definitely implementation specific. There's a lot of things that tie into that. It will also, one thing to take into account is how feature rich the decoding library that we get from ARM is, right? So there will be a lot of things depending on that, how much we can do with it, how much insight it provides compared to what's currently available in DS5 or what's currently being done by Lauterbach. So there's a lot of things resting specifically on that, like on how rich and powerful that implementation becomes. And this is something that we don't have, that we have to talk about this week. Something we don't have much visibility into right now. Like where the development of that library is, what kind of features supported, what's not supported, what we can expect. But in my opinion, a vendor-specific product will always be more powerful simply because you can pull whatever you want in it. You don't have to deal with the community. Since we do everything upstream, we have to do everything by the book. Maybe by the book is not the right expression, but we have to do things that are upstreamable. When you don't have to upstream things, you can do things specific for your target or your platform without caring about what other people might require or might want. So you have a lot more flexibility into what you're doing, but you enslave yourself to redoing the same thing over and over again because the kernel will keep expanding. So we have to talk about this library this week.
Okay.
All right, that's all the time we've had. I'm always available in the hallways. Never been shy to talk to people. Thanks for coming.